Friends, welcome to the lecture 13 on module 2 on the course on risk and reliability of offshore structures. In module 2, we are talking about structural reliability. In this lecture, which is the 13th lecture in module 2, I will continue to discuss the failure domains which we started in the last lecture. So, I will put failure domains 2. In the last lecture, we already said that behavior of general system can be modeled either as a parallel system composed of path sets. So, general system can be modeled either as a parallel system composed of path sets with each path set acting like a subsystem of the components in series. So, each path set will actually become a subset in series. Alternatively, one can also look for a series system composed of subsets or cut sets. Each cut set will become a subset in parallel, as we saw in the last example. Now, as a system in series, composed of cut sets, each cut set will of course become a subset in parallel. Okay. So, the first order approximation of general system reliability is based on the cut set formulation, which I will discuss now, which we already discussed partially in the last lecture. A similar approach can also be developed using a path set formulation in order to estimate the probability of failure of a given general system using cut set formulation. Okay. Now, let us talk about the cut set formulation. So, we know that probability of failure as expressed in the last lecture is simply given by probability of UM then intersecting with I element of CM, that is a subset of GI of x less than or equal to 0 equals number 1. Now, we would like to know that EM is going to the corresponding event, which is section of I element CM G of x less than or equal to 0. So, EM is the event that the parallel subsystem represented by cut set CM. So, EM is actually the event that parallel subsystem being represented by the cut set CM fails. Or cut set failure. Okay. So, therefore, the probability of failure, as we said, is probability of UM of CM, EM, because EM is now the event. So, now we also have something inclusion exclusion theory of the set theory. Then one can write the following statements very easily, which we expressed in the last lecture, and probability of using inclusion exclusion theory of the set theory. One can say probability of failure can be simply given by probability of UE1, which can be said as probability of E1, UE2 as it goes up to U, E, N, E which can be also simply I 1e Pfi, which is minus I j of Ne n minus j minus 1, which is probability of EH. Now, in this case NC is the minimum number of cut sets, comprising the system or identified for the system. Therefore, the above equation can be simply solved by summing the probability of failure of each cut set. Okay. So, solution to equation 3 is sum of probability of failure of each cut set, isn't it? Which is nothing but sum of probability of each cut set I equals 1 to let us say Ne Pi. I mean one can say Nc, please say let us say Nc here, okay, Nc, where Nc actually is the minimum of cut sets we have. So, which will indicate every possible intersection of cut sets, is it not? So, we said that after identifying the minimum cut set C4, which is 2, 3, 4 for the classic quoted example, and C5 is 1 and 4 being the minimum cut sets which are adapted for the given example, we can substitute appropriate sign and then apply the summation series to find the probabilities of failure of the whole general system. So, in this case E4 and E5 will be represented, and we already said E4 and E5 will be actually the events associated with the parallel subsystem okay, with cut sets C4 and C5 fail. Okay. So, E4 and E5 can be simply said as G2 of x less than or equal to 0 intersection of G3 of x less than or equal to 0 section of G4 of x less than or equal to 0. Okay. And obviously, E5 will be, because E4 corresponds to C4, C4 is having elements 2, 3, 4, therefore, we written 2, 3 and 4. Similarly, E5 is having elements 1 and 4, so I should write G1x less than 0 section 1 and 4, so G4x. So, equation number 4, which of course expressed in the last class as well. So, probability of failure is now given by probability of E4 event plus probability of E5 event using the theory of probability what we studied in the last module, probability of E4 E5. Okay. So, we have already expressed E4 probability of E4, probability of E5, then E4, E5 etc. with beta 4, beta 5 etc. Okay. Now, Interestingly, we know probability of E4 in the last lecture, probability of E5, E4, E5, we expressed all of them. We also know beta 2, beta 5, we already know beta 4, then we already expressed the equation for beta 5, we already expressed the equation for beta 4 5, we also know equation for R 5 and R 4 5, which we have given in the last lecture, is it not? I already wrote the matrix and vector for R's and B's respectively for this particular problem. So, now E4 E5 is E4 intersection E5, which can be simply G1 of x less than equal to 0 domain intersection of G2 of x less than equal to domain intersection of G3 of x less than equal to 0 domain intersection of G4x less than equal to 0 domain. Okay. Call this as equation number 6. So, equation 6 represents the event that both subsystems of parallel components fail. Okay. Equation 6 represent that both subsystems of the parallel component fail. So, let us look at the failure domain of this, which shows the first order approximation, which will look like this. So, please pay attention to the system failure domain of first order approximation shown on the screen now. One can see here the failure probabilities using beta 4 5 R 4 5, beta 4 R 4, beta 5 R 5, which we just now wrote the equations on the blackboard. So, the red lines indicates the failure domain, let us say G1 of x equals 0, and this of course indicates G2 of x equal to 0, and this indicates the performance function G4 of x 0, and this indicates G3 of x 0. We are looking for the intersection of this. The shaded portion will show the system failure domain, which is the intersection of all these as seen in the expression or equation number 6. So, G1, G2, G3, G4 are all shown in the screen, which you can see here the failure domains, and of course, the probability of failure phi 4 5, phi 3, phi 2 etc., which you have computed based upon betas and r's, which are given the equations. So, one can find the tangents and one can see the intersections, and the shaded portion shows the failure domain, the system failure domain using first order approximation. Okay. So, the figure showed the failure domain. Of the first order approximation of the system using first order approximation. Okay. For most of the system problems, one can see here that the probability of failure can be estimated even when there is difficulty in estimating phi's of beta. So, the crux of the problem is to estimate phi's function of beta r, even though there are difficulties, but still one can estimate with the estimate of phi in beta r, one can estimate probability of failure of the given system, okay, which has been either replaced by equivalent parallel systems with minimum path sets or equivalent series systems with minimum subsets. Let us say if the probability of failure is given by probability of, let us say, g less than 0 function for a true reliability analysis, then the inequality observed is there in the given component, and the above equation can be now modified. The above equation now can be modified as probability of failure, which can be P of g of x less than 0, okay, less than 0, given, okay, given intersection of h of x, okay, less than 0. The above equation, okay, let us call this as equation number 7. Now, one can also expand this equation slightly in a better manner. Also, probability of failure can be said as probability of g of x less than 0 intersection h of x less than 0 by probability of h of x less than 0. Question 8. So, the additional information provided by this function will be able to adjust the inequality event, will adjust the inequality event present in the original equation of probability of failure for first order approximation. Okay. One can also use this additional information based upon the reliability assessment can be made using the plausible reasoning which we already studied in the earlier modules. Okay. So, Mattson 1987 has given further information on this specific application. Said probability of failure can be redefined slightly from equation 8 further, that probability of g of x less than 0 given h of x equals 0, which can be said as probability of g of x less than 0 intersection h of x equals 0 divided by probability of h of x equals 0. Equation number 9, which can be further extended as probability of g of x less than 0 intersection h of x equals 0 divided by epsilon of p of h of x equals 0, okay, h of x let us say minus epsilon. Equation number 2, which can be further extended as epsilon tends to 0 dou by dou epsilon probability of h of x equals 0, okay, h of x minus epsilon less than or equal to 0 can be said as probability of h of x, probability of h of x minus epsilon minus del epsilon less than equal 0 minus probability of x h of x minus epsilon less than 0 divided by d, which can be as probability of epsilon less than h of x less than or equals epsilon plus d epsilon by d epsilon. Equation number 11. One can see here in equation 11, in this method the probability sensitivity with respect to dummy parameter epsilon is required to be evaluated. Okay. Probability estimates with respect to dummy parameter epsilon is evaluated. Okay. So, friends, in this lecture we discussed about the failure domains, how it is extended further, and how one can actually find out the failure probability of a general system which comprises of either minimum path sets parallel system or minimum cut sets series system, where essentially they converge to failure of the minimum parallel system with minimum path sets leading to failure of subsystem of system in series, whereas minimum cut sets lead to subsystems fail in parallel. So, both of them will give obviously the same answer as we discussed in the last lecture as well. So, here we have already told you how to compute the first order approximation, and we also showed you the failure domain of the general system comprising of cut sets, minimum cut sets in the presentation. So, the equation can be further modified to find probability of failure as given by Mattson 1987. So, one can find out the probability of failure by identifying the intersection of different failures, of course, with respect to a dummy parameter epsilon, as you see from this equation 9, 10 and 11. So, I hope the module what we discussed so far to understand the first order second moment onwards different system reliability and component level reliability. We have also discussed about the system reliability derived from the component level failure as subsets of the main system using path sets or subsets, which we already discussed with cut sets and path sets. One can easily find out the probability of failure of assembly of this as intersection or union of the failure domains given by different surface domains of different variables. So, we will also look into some application problem of this very quickly in the next lecture before we move on to further extension of this for higher order reliability theories. Thank you very much.